All right, here we're going to be looking at section 2.3. And our essential question is, what is the focus of a parabola? So let's go ahead and look at that right now. So I know I generally have my parabola, which we're just going to look at kind of a general form right here. So the focus, and we're also going to be dealing with the directrix, the focus is a point that is always inside the curve of my parabola. And then I have a line that's called the directrix. And that's always outside my parabola. So what a parabola really is it is all points that are the same distance from this focus and the directrix. So this distance is the same as this distance. And just like if I'm using a different color, if I go here, these two distances will be the same. Right? You can't really tell that in my drawing, but that's really what a parabola is. So remember, focus is always inside and my directrix is that line outside. So let's look at our learning targets. First, we're going to explore the focus and the directrix, and then we're going to write equations of parabolas. So we've been given some equations and we've been asked where they've moved, what transformations have happened, and now we're going to actually be writing equations, and then we're going to look at some real-life problems. Okay? So first, we're going to use the distance formula, and I'm going to show you an easier way to do this, so don't let this kind of freak you out or overwhelm you. So first, we're going to use this distance formula to write this equation, because we can do this without the distance formula later. So like I said, these two distances are the same. From point F, which is my focus, to the point P on my parabola is the same as that distance from that same point P to the directrix, which we're going to call it at D. Okay? So since those are the same length, I can set them up the same. So I'm going to use my distance formula twice here. Okay? So I've got the distance formula to find the length of PD and the distance formula to find the length of PF. That's what these two are. So now I can plug in the values that I know. Okay, so I know the point here. I'm going to use x and y for this point because I don't know that for sure. And then I have x comma -2 because that would be this point right here. So I plug in all of that information into my distance formula for each piece. I simplify. Then I square each side to get rid of my radical sign, and then I expand my binomials. And then I combine terms and divide each side by 8. So this would be my final equation. Okay, I'm going to walk you through a much easier way to do that in just a minute. Okay, so here's our core concept. The big things we need to keep in mind here is now you see that I have some parabolas opening towards the side, right? These are not functions, but we're still going to be dealing with them. So the big difference here is I've been dealing with these y equals. And you'll notice that a y equals opens either up or down. And I like to think about this as that it's going around my y-axis. Right, so even if it opens up, it's around this y-axis, and down is around the y-axis. Here I have some x equals. Well, that I can see are these sideways ones that are opening around my x-axis. That's the big thing to keep in mind. The other thing that you absolutely must know is this 1 over 4p becomes my a value. Okay, this is going to become very important. So just remember 1 over 4p, 1 over 4p. And we'll talk about what p is in just a minute. Okay. So identify the focus, directrix, and axis of symmetry of this equation. -4x equals y squared. And then graph the equation. Well, I like to kind of graph it first before I get too far so I can see what I'm looking at. But I notice that this is not written in any form where I can just look at the quadratic. So I always want to get the variable that does not have an exponent by itself. So that's going to be our first step. So I've got -4x equals y squared. So I want the x by itself. So I'm going to divide by that -4. So x equals a -1/4 y squared. Okay, so now I see that it's written the correct way. So the first thing I notice is that it's an x equals. So I know it's either going to open to the left or to the right. Well, so now I can look at this negative sign, and this negative sign tells me that it's going to open to the left because it's opening around the negative part. This 1/4 tells me again how big and skinny it is, tall and skinny it is. Okay. So I have to find the focus. So to find the focus, I have to find my p value. And I know that I have 1 over 4p. Always, we're going to start here, 1 over 4p. So I can take that, and I can set that equal to this 1/4. Well, seeing these fractions together, I know that p is going to be equal to 1. So in order to find my focus, right, I know here that my vertex is at the origin. My focus is going to be inside the parabola, and the directrix is outside the parabola. So this p value tells me how far away my focus is. So this right here is a distance of 1. So I know that my focus is going to be a -1, 0. I also know that that is the same distance that's right here. So this will also be a distance of 1. So my directrix is always going to be written as a line. Lines that go up and down are x equals, and here I'm told it's 1 away. So this is the focus right here, and this is the directrix. And you can do that following these steps on this page, like find negative p and positive p and put them in places, but for me it's just a lot easier to draw the graph and kind of say, oh, well, my focus is inside, so that would be a -1, 0, and here's my directrix out here. So now the axis of symmetry. And remember, the axis of symmetry is where I can fold my graph and it looks exactly the same. So I see my axis of symmetry here would be the x-axis, because if I fold along here, along my x-axis, my graph is exactly the same. So here's another example. So we have to write the equation of the parabola. So the first question I ask, is it going to be x equals or y equals? Well, here my parabola is surrounding or going around my y-axis, so it's y equals. Then I know we're going to have an x squared. I see that my vertex is at the origin, so I can leave it just like that. Now I ask, is this going to be positive or negative? Well, I know it's going to be a negative because it's opening down around the negative axis. So now I have to deal with my 1/4p. Well, so now let's find what p is. So I have y equals -1/4, and my p is always the distance from the vertex to either my directrix or my focus. Here I'm given the directrix, so I can just count. So 1, 2, 3. So my p value is 3. So now let's simplify. So y equals a -1/4 times 3 is 12, x squared. So I know that this is going to be the final equation of this parabola. Okay, so now we're going to look at some parabolas with my vertex that's not at the origin, right? So again, here are some rules you can follow, but we're going to do something very similar. The big things I want to note here is, again, I have my y equals and my x equals, but here's where it gets a little bit differently. Since in my y equals, I have my x in my parentheses, I'm always going to have my h in my parentheses as well. So down here you'll see, since y is in the parentheses, I'm going to use k in my parentheses because my vertex is h, k. So h is the x value and k is the y value. So those have to go with the correct variable. And you'll always notice, I've told this before, that inside my parentheses it's always x minus, or in this case y minus. And then we can use our plus outside, but it's always going to be x minus or y minus. So let's look at some examples of this. So we have to write an equation of the parabola shown. And again, I have my vertex, I see the focus, I have everything I need. Okay? So the first thing I'm going to ask, is this going to be x equals or y equals? Well, it's opening around my x-axis, so it's going to be x equals. Okay? Then is it going to be positive or negative? Well, it's going to be positive because it's opening towards the positive direction. So now I know I'm going to have my 1/4p. I see that my vertex is not at the origin, so I know I'm going to have my parentheses. And I just have to figure out, so my y goes in here, I have to figure out what these two values are going to be. Well, so my vertex, let's go ahead and find, is going to be 2, 4, 6, 2. That's where my vertex is. And I just counted using my graph. Okay, so now I know, since y is in here, my y part of my vertex has to go in there. Since my x is out here, the x part of my vertex goes there. So now all I have to do is find my p value, right? So here's p. So p is always that distance from the vertex to the focus. So here I see I go 2, 4. So my p becomes 4. So now we just have to kind of simplify. So I have x equals 1/4, and I said that p was 4, times y minus 2 squared plus 6. Well, here I can do just a little bit of multiplication. So I end up with x equals 1/16 times the quantity y minus 2 squared plus 6. So here is the final equation for this parabola. Without having to just memorize a bunch of equations and without having to use the distance formula, I found everything that I needed to write my equation. So we're going to see several of these. These are kind of our real world problems. And our real world problems really often deal with like satellite dishes. So here I'm told I have an electricity generating dish using a parabolic reflector, which is this here, to concentrate sunlight onto a high-frequency engine located at the focus of the reflector. So I automatically am told that this is my focus. The sunlight heats helium to 650 degrees Celsius to power the engine. That is information that I don't really need to solve this problem. So write an equation that represents the cross-section of the dish shown with its vertex at 0, 0. So here's my vertex. And then I'm asked what is the depth of the dish. So the first thing I have to write is the equation. So I'm automatically going to here's my y-axis and my x-axis. So first question, is this a y equals or an x equals? Well, it's going to be a y equals because it's going around the y-axis. Then my next question, is it positive or negative? Well, it's going to be positive because it's opening up. So now I'm going to deal with my 1 over 4p, and I've got my x squared. And I know I can use just x squared and not have my h or k because I'm centered, my vertex is at the origin. So now I have to find my p value. Well, I'm told that this point was my focus, so I see the distance from my vertex to my focus was 4.5 meters. So I have y equals 1 over 4 times 4.5, x squared. Well, this can be simplified, so y equals 1 over 18 x squared. So this is the equation that models this parabolic dish. So now the second question I've asked is, what is the depth of the dish? So the depth I know is going to be the height when my dish is right there. So this is going to be my value that I'm looking for, the height of my dish. Well, I know that that height is a y, and I see here I have my equation that models my parabola, but I also know that I have this x value. And this x value would be 4.25, because this is just half of the entire length of my dish. So what if I go ahead and I put that in for my x squared? So now I have y equals 1 over 18 times 4.25 squared. So now I've plugged this in, and if you go and plug this in your calculator, this 4.25 squared gives you something like 18.04 something. So this is really close to 18. Then when I multiply it by this fraction, I end up with approximately 1. So the depth of my dish is approximately 1 meter. Okay. So that's actually all there is to this section. So let's look back at our learning targets. Okay. So first we looked at the focus and the directrix of the parabola. Then we wrote equations of parabolas. The big thing to make sure you can do is if you have a parabola where the vertex is not at the origin, right? That just adds an extra little step that we need to do. Just remembering that our k value always goes in with my y, and if I had a y equals, it would be that h value. So always make sure your y's go together and your x's go together. So we wrote some equations, and then we looked at some real life problems. We took that dish and turned it into just a parabola that we've seen before and used those numbers. So now that you've gone through these, make sure that you can follow. You do not have to use the distance formula. Even if it tells you to use the distance formula, you don't have to. So just follow those steps that we've done here and go ahead and work on the homework for this section.